Hey guys, I'm Gabe Ochoa, and I'm here at the Invention Studio at Georgia Tech, where I'm an undergraduate laboratory instructor, and I teach people how to use everything from lathes and mills to our laser cutters, 3D printers, and our big water jet in the back. Help people with their projects, anything they want to make or build, or if they've got questions, any major, it's all free to use. It's a wonderful build, maker, and hacker space. I want to show you all one of the projects that I'm currently working on. It's a 3-pound BattleBot for competition, about a week and a half. As you can see, I've still got some more work to do on it. I'm missing a top plate here, as well as the bar spinner that goes across it. And I'll hopefully have those done in the next week so I can get some testing done with it. It's powered by a 3-cell lithium polymer battery. So it's 11.1 volts. It powers both these DC brushed motors, gearhead motors here for my drivetrain, as well as a 30 amp ESC for my brushless motor that powers my bar spinner weapon. This is a 600 kV brushless motor. It's an outrunner for a little bit more torque rather than a little bit more speed. The bar will hopefully be spinning around 7,000 RPM, which should give me just enough energy to bite into the other robots and not necessarily mill or machine them instead, because you want a nice bite and a nice kick to them. The weapon, when spun up, will have just over 800 joules of energy in it. That's at full speed, so I'm hoping that that's going to do some damage, which it should given the small form factor. I'm taking off the side armor here so I can show you all the weight saving techniques that I kind of employed here, a little bit in the wheels as well as in the actual aluminum frame structure, just a nice little truss there to cut some weight, as well as these notched pieces that are angled at 60 degrees for my armor, such that it's actually a nice, because it's a nice deflection angle for other robots coming in and their weapons. That was found mainly through testing and through other people who've been doing this a lot longer than me, gave me that advice. All of the sides here have positive locators as well as holes for the screws to actually screw the plates on, and positive locators help them maintain position as well as make it easy for me to assemble and disassemble in a relatively short time span. It's a nice compact form factor. Hope it's going to do well. The steel actually is 1095 carbon steel that we took and heat treated ourselves in-house. It was a very interesting process. Unfortunately, we don't have a very precise temperature control on the kiln that we used, so it was didn't necessarily give us as precise of results as we would have liked. But as you can see on this other side that I took off, it came out fairly well once I ground down the oxidation off the top of it from the actual quenching and tempering process. Other than that, hopefully it'll do well in a couple weeks. We'll see. This is what I spend my free time on, what I love doing. You see, I'm actually going to attach, or there's actually an exploded CAD view that you should be looking at now. It's very intricate. There's lots of small pieces. There's over 24 unique pieces in this small thing, which has been kind of a challenge for me to machine in the short time span. Only 3.5 weeks till competition, I decided to start building this. So that's this. Hope you all enjoyed it. If you have any more questions or want to see pictures, and hopefully there will be some more complete pictures by the time y'all check them out, go to my website at thebuildingexperiment.com or check out gabeochoa.com. They both go to the same place. Thank you very much.